All right, so I'm being told that the screen froze on me, and because of that, I'm going with I'm going with the blame game. Camtasia, this is on you. What the heck, bro? So hopefully you can see the screen now, and we're gonna go and solve this one once again. Yeah, so hopefully you can see the screen and everything is just sort of blank. It's not like you can get much out of this. And so where I go with is this then right here. So I'm going to solve this a little bit differently because why the heck not? I can look at this battery and go, oh, look, this is the power of the battery. This is the current through the battery. And I do know that the battery is providing 18 volts. So I can use the fact that the power is equal to the current times the voltage, and I can't get anything out of that actually. Never mind. So instead, what I'll do is I'll draw another circuit. I'll do what I did last time. I'll draw a simple circuit like that, and basically the way that this circuit goes is that this is Req. This is the equivalent resistance that if I were to add up R1, R2, and R3 in series, that would give me the equivalent resistance of that thing. So the voltage of the battery is still 18 volts, but what is this equivalent resistance? Well, as we learned in our series investigation, the equivalent resistance for something in series is literally just adding up R1 plus R2 plus R3. And so that's going to be 7 ohms plus 12 ohms plus 17 ohms. So what does that become? So we got 24 plus 12 is 36. So this comes out to be 36 ohms. So this is 36 ohms. All right. Yeah, and then basically I can say, well, then the current going through the battery is the same thing as this current right here, I, and I can find out what that current is because Ohm's law. So Ohm's law says I equals V over R, so the voltage is 18 volts, the resistance is 36 ohms. And that means then that the current going through the battery is 0.5 amps, and that's the current then for a series circuit going through the whole circuit. So that means basically this is 0.5 amps, this is 0.5 amps, and this is 0.5 amps, and this is 0.5 amps. Now I can calculate what the power is through the battery. It's going to be the current multiplied by the voltage. So it's going to be 0.5 amps times 18. So it's going to be 9 watts. So that is that. There you go. All right, and let's see. So so now it's just knocking stuff down, right? Because the voltage is going to be the current multiplied by the resistance. So the current is 0.5 amps. The resistance is 7 ohms, so that's going to be then 3.5 volts, because 7 times 0.5, I think is 3.5. Hopefully, fingers crossed. And then the power is going to be the current multiplied by the voltage, which is going to be 0.5 times 3.5, and I'm not 100% sure what that comes out to. What do we got? Sorry, I don't want to think. 3.5 times 0.5, 1.75. So I think that's right. All right, and then over here for V2, it's going to be the current multiplied by the resistance. So that's going to be 0.5 times 12, which is going to be 6. There you go, 6 volts. And then the power is going to be the current multiplied by the voltage, which is going to be 3 watts. There you go. Right, because it's going to be 0.5 amps times 6 volts. All right, so then over here, it's going to be the voltage multiplied by the current, which is the current multiplied by the resistance. And so 17, let's see, it's 8.5 volts, I think. Because, yeah, 8 times 2 is 16 plus the 0.5. Okay, yeah, that'll do it. So I think it's 8.5 volts. And then to get the power, it's going to be the current multiplied by the voltage. So it's going to be 0.5 times 8.5, which is 4.25. So let's triple check again. All of this, the voltages should add up. So 3.5 plus 6 plus 8.5. And we get 18 as a result. So this is all checking out. And there you go. That's how you do it in series. The current is the same, and then the voltages add up, which is the opposite of what it is in parallel. Okay, hopefully you saw that. Sorry. Bye.